Hey, welcome to Object-Oriented Programming. This lesson is going to be on objects and characteristics of objects, introduction to objects in Java. Um, this is meant to be a beginning and introduction thing. We're going to get into the more um, higher minutia level of object-oriented programming later on. But for this case, this course right now, what we're going to be going through are different types of topics for our interest for today. Sorry, I'm just going to move my head. We're going to do these three topics right here: what an object is, what a class is, and different characteristics of objects. We're going to move into static methods, constructors, cookie cutters, and dot notation later on in the course. But until then, we're going to talk about objects. And so, what an object is. What makes an object? So, the human brain itself organizes our thoughts and memories into objects and their relationships to each other. So this is like, think about the last time you guys had breakfast on Saturday with your family. You had the smell of bacon, the sound of crackling eggs, maybe the smell of pancakes being cooked on the frying pan as well. Those are all memories that are attached to different smells and sounds and sights that your brain has organized to it. So you might have that memory of hearing or smelling bacon crackling on the stove or campfire even. You've attributed to, okay, so that smell reminds you of that event, right? Those are two distinct memories. Those are two distinct objects in your brain that your brain has then linked them together based on the relationship to each other. So like for me, my grandpa operated a trucking yard in the back of his acreage, and so the smell of diesel and gasoline for me always reminds me of Grandma and Grandpa's house. So I probably shouldn't like the smell of gas and diesel, but I do because I've attributed that memory to that place and that time period in my life. Object-oriented software is designed to match the thinking style of our brain. So like here's this behavior, here's this characteristic, and then you link those together as an object in your programming. So some examples of objects and non-objects. So one object would be the pen, right? It is a physical. It has a different state. It has different behavior. So this is one object. This, however, the upper 37% of the pen is not an object. It's either an object or in a whole or not, right? So this portion of the pen is not an object in itself. It's only in relation to the pen itself that it's an object. Another example would be the computer keyboard that you have in front of you or in front of me. That's it. That is an object, but the air above the keyboard is not an object. Your shoes are an object, but the color of the shoe is a characteristic of the shoe itself. It is not an object. The computer mouse is an object, but the sound of the mouse click is not an object. That's a behavior. Characteristics of physical objects. Physical objects are made out of tangible material. They are held together as a whole. So like the whole pen is the object. Fog would not be an object because it's not held together as a whole. It's dispersed. It has different properties. So in this case, it has a white and a black color as well as a silver color. How thick it is, right? So there's this pen. It writes in black ink, and then it has a highlighter. Those are all different properties of this pen. It can do things and have things done to it. So I can use this pen to write. So it can actually write and do stuff, and I can use it to make other things with it. I can also refill this if I wanted to. This is a cheap pen, so I wouldn't. But if I had a nice fancy pen, I could refill that the ink, and I can customize it. I can take this apart. I can do things to it, so that is why it is an object. So that is some characteristics of physical objects. But more specifically and more accurately, these are some more accurate characteristics of objects. Each object has an identity. So each object is its own object. It's not tied to something else in order to be an object. So this pen is one object. This pen is a completely separate object. They're both distinct individuals. This one's black, the ink. This is blue ink. Right. This is translucent. This is opaque. Okay. Objects have a different state. Right, so they have properties that may change. So this can, when it's clicked out, I can write with it. When it's clicked in, it cannot write. If I take the cap off, I can highlight with it. So it has different properties and it can change. It has behavior. So like I said, it can do things and it can have things done to it. So the three more accurate characteristics of objects is they have identity, they have a state, and then they have a behavior. Software objects, they have those three characteristics as well. They have an identity, they have a state, and they have a behavior. Right? They exist entirely within the computer system, and they interact with other software objects. And they're made up of computer memory. So rather than making up of physical objects, it's made up of computer memory. Software objects, they're each a distinct block of memory. So even if they're the exact same, they have the exact same behavior and they have the exact same states, they are completely different identities. So they are, even though they might look the same and they might behave the same, they are completely different, just like a tennis ball. All tennis balls pretty much look alike. They all bounce. They are all made of felt and rubber, but each one is an individual, even though they all look the same or look very similar to each other. Some of the memory makes up a software object is used for variables that contain values, and those values are the state of the object. Software behavior, objects behavior. Some of the memory that makes up a software object contains programs. Those are called methods that enable the object to do things. So that would be the length method or the next line, the keyboard scanner. Those are all different methods that you can use in that object that influence its behavior and what happens. So the object does something when one of its methods runs. So I'm just going to move my head here so you guys can see this a little bit better. What we all work with is more or less a von Neumann computer. So von Neumann computer uses general purpose memory to store both the state as well as the behavior of objects. So if you look to the right here with our little diagram, hopefully this translates well to video. You can see the little yellow bricks. I'm going to just zoom in here so you can see it a little bit better. Turn off pen and zoom in. Okay, so if you can see this a little bit better, we have our data and our little yellow bricks here. We have our location in computer memory that's stored, so we have our address in memory. The size of the file or object that is being stored. It all has that characteristic. So where it's stored, how big is it, and like for instance, color, right? So what's the color of that object? Is it blue? Is it red? Is it yellow? Right? And then within that object, we also have methods. So like maybe this is a red, yellow square moving around the screen there. It would have a move method in there. If I wanted to resize my window, for instance, make my head a little bit bigger, I could. This program's using a resize method here, or I could move my head around the video, and you can see that working there. So those are all different methods that you can use in your programs. This idea was theorized in the 1940s. It's still used today. A software object consists of both variables, so that's the state information, so what is in there, and methods. So the methods are just recipes for behavior, like I showed you. So in this individual image, the yellow bricks represent bytes of memory. The object has variables, so location, color, and size. And then the methods below control the behavior of that object. So when a program is running, objects are created out of the main storage of the computer, and they start doing things by running methods. So what this looks like is you have a computer there, ignore my drawing skills here, and within memory we make an object. Okay, and that object tells the computer to do things. Okay. Easier to read, so do things. Okay. This is done by running methods. So for an application to the first method that's going to run is the main method. So in Java, this looks like the static void main that we've been working with. This is the first method that runs in our Java program, and then that main method will create the objects within that program and use their methods as well. A class is a description of a kind of object. A programmer may define a class using Java, or it could use a predefined class that come in class libraries. So far in class, we've imported, you guys have imported the utility as well as the input-output. You've imported math. Those are all classes that have been predefined, and so you're importing that, so you're not having to redefine those methods and classes. So when a programmer wants to create an object, a new operator is used with the name of the class, and that's called instantiation. Okay, so this is a definition. So instantiation is when a new operator is used with the name of the class. So you have created that class. Okay, I'm just going to move my head. Okay, so this is a class example in Java, so public class string tester. We have our main method right here. So this is first method run. We have our string. We're calling it string1. This is a variable that may refer to an object. So in case you were wondering, I want you to think about this. What is this called? This is where you declare. Okay, so you've declared that object, or you've declared that variable. Okay, the object doesn't exist until the new is executed. So, and then we have another one, integer len. So length. Length is a primitive. Len is a primitive variable of type int. Okay. We have our string right here. So string1 equals new string random jottings. This is where you are initializing. Right there. So we declared it here, but we've actually created it here. So this is where it actually gets created. The length option. So again, we made this here. Okay, so we are now initializing the len variable, and then this is string1.length. So this is a method. Okay, this is our method right here. Okay, and we're using the length method. And then we print it out right here, system.out.println. The string is, and then we're doing concatenation, so plus len, and then characters long. Okay, so that is our class example of creating an object. Objects and names for objects. We want to always make sure that we are using good names for objects, make it mean something, right? So str is short for string, and this is the first string. Len is probably not a great name to use. You can. it's probably okay. Just make sure that you're using proper names, not proper names, but use meaningful names for your objects. Okay. Using a reference for an object. So right here, that's what we did in the first example here. So we've declared our objects right here. So it's a bit of memory stored over there, and now we are referencing it right here. We're referencing it right here with string 1. Okay. So this is the object, and then this is the reference right here. Okay. And then you have the object right here. That's another reference. And this is another reference. Okay? And that is the end of today's lesson.